Hi guys. So this one is okay. First off, I'm using a blue marker because somebody told me to. Second off, I'm gonna try this one. This one's hard because I don't know lines of sine, laws of sines and cosines well. So first, I'm just gonna write them out. First, we have we have a over sine of a is equal to b over sine of b is equal to c over sine of c. And then we also know that a squared is equal to b squared plus c squared minus 2bc cosine of a. Okay, I don't know how that can help us here, so let's read the problem. Consider the acute triangle xyz with an area of 14. If xy is equal to 7, xz is equal to 5, find the value of yz squared. Okay, so if we have here xy, we'll make this xy, we'll make this xz, so that's 5. That's a bad Z. C, that is X. This is 5. This is 7. So now we just need to find the area, or we know the area of this triangle is 14. Okay. Is there a way we could find the area of this triangle without knowing what Z is? I don't think so. Or what YZ is? I don't know. How can we use laws of sines and cosines to help us? Well, we know it's acute. We don't know any of the angles themselves. But we know it's acute, so we know that every angle is less than 90. Oh, okay. Hmm. It's not like this is a right triangle where I can... Huh. Well, okay. Let's say yz squared is equal to 5 squared plus 7 squared minus 35 cosine of a. So this is 25, this is 49, which gives us 69, 74. 74 minus 35 cosine of a is equal to yz. So now we just have yz dependent on x. How do we get that angle right there? We don't know any of the angles. This depends on the area. We haven't used the area yet. How do we use the area? Because for all we know right now, this triangle could be anywhere from here to here. No, anywhere from here to here. Like this. No, but it has to be, it can't be farther, because that would make it obtuse. It has to be like that. Not farther than here, not longer. Oh, that's so weird. So it's really just anywhere here it can be. It's like a rectangle. I thought it'd be a circle, but now it's a rectangle. Anyways, so how do we know which one it is? Well, we have to use the area, of course, but how do we use the area? Is there a way we can use the area? Like, input side lengths of the triangle and get the area all the time. I don't know. We can't use SOHCAHTOA, I don't think, because I think it's only for right triangles. Okay, I think for me personally this is a lost cause, so I'm just gonna give myself a little bit of a hint, and I'm gonna look up side length to area formula triangles. Oh, use Heron's formula. I thought that was for quadrilaterals. Okay, so we know A, which is the area. 14 is equal to the square root of S. Oh, this is gonna be really bad. S times S minus A times S minus B times S minus C. We know A is 7, 5. C is unknown. C is going to be our unknown. S is equal to 7 plus 5 plus C over 2. So it's going to be equal to 13 plus C over 2. So 14 squared, which is 196, is equal to this big thing. We're just going to do this with a huge polynomial. 13 plus C over 2 times, I'm going to change this to be 13 over 2 plus C. So 13 over 2 plus C times, this is also 6.5, so C minus 0.5 times C plus 1.5 times 13 over 2. So multiply by 2 divided by 13, we get 196 times 2 over 13 is equal to this, which is a cubic in terms of C. We're not going to be able to solve a cubic, especially with fractional components. So I think that's a lost hope. What else can we do? Hmm. Maybe we could use law of sines, maybe? We could say uh, A over sine of X is equal to 7 over sine of Z is equal to 5 over sine of Y, I guess. But this doesn't really help us, because we don't know sine of z, we don't know sine of x, we don't know sine of y. Unless, do we know like they're when they multiply together? No, we don't. Only if we knew cosine of x. Well, we know that the answer must be an integer, so cosine of x is going to be equal to some kind of rational number. It's going to be it's going to be one of these. It's going to be 1, 5, 5, 7, 35 on the bottom. Sorry, I just got a text. And on the top, it's going to be any number from, it can't be any number. It depends on the number on the bottom. But it really is restricted from 1 to 35. So I mean, I guess we have, and if it's like, if the number on the bottom is 5, it's restricted from 1 to 5. I guess 1 to 4, really. And then, okay, so I guess we have a good idea of what the answer could be. But, well, okay, so let's say we put 5 on the bottom. The answer is always going to be less than 35. Or the 35 cosine of x is always going to be less than 35. So, hmm. Hmm. Maybe we can pretend we know this one, and then find the area using, like, base and height. So, like, let's put this here. So, this height is, we just know this height times this, plus this height times this over 2. This height here is, this is a right angle, this is a right angle. I could use, so we should use cosine of x. K is adjacent over hypotenuse. We don't know what this is here, actually. We know hypotenuse. H is equal to, no, yeah, I guess we need h. What is h equal to? H is equal to, I guess, 5 times cosine of x, which is also equal to yz times cosine of y, and then area is equal to 14, I guess, is equal to 1/2 height times, it's just going to be 7. So 14 is equal to 1/2 times 35 times cosine of x. So 28 over 35 is equal to cosine of x. This is the same thing as 4 over 5. So our answer is 4 over 5 times this. So yz squared is equal to 74 minus 4 over 5 times 35. This is 28. 74 minus 28 is just, this is 14, this is 6, this is 6, this is 4. 46 is our answer. I'm very sure. I actually got it incorrect because I somehow messed up that this is not, that this is incorrect. It's actually 32 because for whatever reason this is sine of x, this is sine of x, this is sine of x, which makes cosine of x equal to 3 over 5, which makes this equal to 74 minus, I'm not sure actually, but I know I got it incorrect. But I'm happy I actually got a foothold because I was really stuck there, but I got on the right track, so I was closer than I would have been if I gave up when I looked up Heron's formula. So, cool. Thank you guys for watching. I'll see you guys tomorrow. Bye.